Hello and welcome to another episode of Free Code Friday. My name is Jason Bach and this is episode 20. And I've just completed, well, not um, just completed putting up 7 episodes, I'll say, of this show on YouTube. I edited all the first 19 a while ago, and now I've just been posting them every Friday. And it's been an interesting experience, learning what to do, what not to do, how to handle this, some more ideas on future episodes, and so on and so forth. So, one of the thoughts I had was that I will keep doing this through 2018, and I'll keep doing it just on Fridays. But then after that, I'm going to start maybe looking to see if to break these up into you know not just once a week. Do it whenever I want. So change the name of the channel or start a whole new channel with episodes. I don't know. Well, I'll see. I'll see how I do this. But I enjoy it. I'm not dismayed that I'm only getting 10 or 20 views. That doesn't really bother me right now, nor would it. I'm doing this because it's fun. It's interesting. I like the idea of doing code on the fly. Trying some ideas out on the fly, though today the stuff I'm going to show isn't necessarily on the fly. It's going to be a lot of pre-canned stuff because I've actually just been tinkering with these ideas for the last week or so. I actually recorded the episodes and I didn't like them, so that's why I'm doing it now. But in any event, I do like just the spontaneity of coming up with a topic and just diving into it and seeing what it's like. So so whether I get 20, 200, whatever, however many people view this, fine by me. I'm happy with it. So, what I decided to do today or in this episode, I should say, is to go through just a couple small things I noticed as I was editing the videos, and just cover a couple small topics in rocks. I'm going to do something with editor config. Maybe they'll bleed into another episode. I really want to keep these to 30 minutes, give or take a small delta, but I don't want to make these too long. A couple of them I went over, and I'm going to try to keep these around 30 minutes, so I may stretch this out to another video. I'm not sure. We'll see. But once I get this little set done, then I've decided I'm going to kind of branch out into 2 ideas. One is a library that I've wanted to write for the last year or so, come up with ideas basically to modernize a framework that already exists. So I'll be working on that and kind of doing it live here and showing how I put everything together and what works and what doesn't, kind of what I did with editor config. And then I want to work on a compiler for kind of a silly language. You'll see what it is later on. I've never written a compiler before, so I have no idea what I'm doing. I have the Dragon book, kind of glanced through it once or twice, just a couple of the first chapters, and that's about it. So I don't have a lot of experience. By a lot, I mean none. I've written an interpreter, but I've never written a compiler. So that will be a learning experience and will be probably very humbling, but I want to do it. I want to see how it turns out and just have some fun with it. So those are the kind of 2 things I want to do, and maybe throw in an episode here and there just to see, to break things up. But that's kind of the plan for the rest of the year. Given all that, what am I going to do in this one? So the first thing I wanted to do is make rocks tests run in parallel. And the way that you do that is, where do I have that? No, not in rocks. That would be in rocks tests. Is it in properties? Nope, that's the that thing. Where do I have those? Shared. Okay, yeah. So that's this thing right here that I'm trying to highlight. That's what you can set to make your test run in parallel. Now, I did this with editor config generator, and I played a little bit with having it in and then not having it in code, running tests, not and see if there's any difference. I also have this thing pressed here. You can see is run tests in parallel. And I'm not sure if that actually matters or not. It's been kind of a confusing experience. Sometimes watching the processors and Task Manager and seeing are they being pegged or not. If I don't have these on, do all the processors get pegged? I don't know. It didn't seem like I was getting a big difference here. I was in Editor Config Generator, but not here. And it was a little weird why. So I went through and kind of went through the 4 cases. Turn this attribute on and off, and then turn that button on and off here in Test Explorer. So I got some data here, and so what do these mean again? I forgot. So NUnit is the attribute, and tasks test in parallel, the tip is on, and NUnit is on. So those are the 4 possible combinations, and I would run them in release mode. I'd ignore like the first 2 runs just to ignore them, and then I'd just run them 5 more times and see what I get. I really don't see a huge difference here. I mean, you would think that this one on and on would be the fastest, and technically it is, but the worst is not with both of them off. The worst, quotes there, is if you have tests in parallel off, but NUnit is on. But again, this isn't that huge of a difference. It is a difference. Arguably, it's a half a second difference. Though I'm not convinced it's always that way. Like you saw one run up here at 16.9. You did get a run of 16.65, which is close to like this one. So I'm not really that convinced that it's that big of a difference. But it definitely doesn't hurt to have it on. It's no better or no worse. I would like to have a little bit better understanding as to how this parallelization of tests works in Visual Studio and NUnit, but whatever. Whatever the case is, that's what it is. So I'm going to check this in eventually. Now you'll notice if I come to, where are you? GitHub Desktop. That I did make a branch. I just started coding and I did the bad thing, and I've got a bunch of changes here. The thing that I started to do is also look at some little optimizations. And what I mean by that is, in one of the videos, if I get up here to rocks and I go into, this one. So generating a name. You can already see I've got the change here. I've actually got to go into history here and show. You can see right here that what I would do is actually create a new GUID. What I'm trying to really do is make sure that I always generate a mock with a name, a mock type with a name that is always going to be unique. And the easiest way to do that is to use a GUID in the name. The problem, it's not really a problem, but the problem is that that's a little heavyweight to actually have to generate a GUID. Was there a better way to maybe just use an int? And this is also a little bit of my paranoia. I think putting just rocks there, or I'm sorry, rock in front of the class name, is probably going to be more than sufficient to always have a unique type name. I highly doubt I'm ever going to run into the case where me putting the word rock in front of a type that I'm generating in runtime is going to collide with a type that already exists in somebody's assembly. But if I don't do this, I'm sure it's going to happen. So I want to try to put something unique, and I thought of maybe doing like a incrementing identifier, it being an integer. That was one idea that I had. And then I started thinking about it, and I went, every member in an assembly has something called a metadata token. That's what you see here. Let me jump back to the code. Okay, and that token is going to be unique within an assembly. So that's probably good enough for what I need to do. So I said, would it be cheaper? Cheaper being performance and speed and memory, to use a metadata token rather than a GUID. And so I started running some tests in benchmark.net. Now, before I show you the results, a couple of things. One, this is just an int, okay, but I was trying to look through the code, and trying to search through the code is not always an easy endeavor. You can, it's all open source, but as far as I can tell, this is not a simple get from a field. You actually call some runtime type handle or something like that, runtime type handle or some method like that. I forget the actual name. But there is a little bit of a cost involved. As you're going to see, it's not as much as using a GUID, so I'm fine with this. It's also a little bit cheaper from a memory standpoint. Okay. The other thing is I just found out, I'm running my tests, and tonight benchmark.net actually announced that they have a 0.11 release, which they said you can start using argument source attribute to pass in arguments to a method parameterization, which I find to be easier than what I have been doing, which, for example, if you see type name generator tests, I have been using this iParam and IEnumerable and having to set the property here in param source, and I don't really like that, but it works. I tried to upgrade to 11 and change my tests so that they're actually taking parameters. That didn't work for whatever reason. Either I'm not doing it right or there's some bug in the current release. And I thought, okay, well, fine. I backed out all my code and just changed it back to the way you saw it, but I left benchmark at 0.11. That also fails. My tests actually don't run anymore. They actually bomb out, which is weird. So I posted something in the Gitter channel, and first I just thought I was doing argument source wrong, but that may not be the case. I'm not entirely sure that the 0.11 release is fully stable. I'd say it's probably stable with stuff, but it definitely it will break these tests the way I have them right now. If I just upgrade to 11 and run these, they won't run. They'll just fail. No other change than that. So a framework breaking that badly is not a good thing in my book. So I've stuck with 0.10, 0.14 for now. I hope they do fix this. I hope they fix these things, because I'd much rather pass in arguments. I wish they had, this argument source attribute is a lot more appealing to me. I wish that would be in place, because then you have to create these custom iParam things. They're just, they're kind of a pain. Just annoying. It'd be cleaner to do it that way, but it just doesn't seem to work right now, at least for what I'm doing with types. So, in any event, what it is, I pulled out the code here to basically mimic what I'm doing, and then do this, which is essentially kind of the same thing except doing the metadata token. And I also wanted to do it against CLR job and core job. Now, one thing I also found out is if you do this, you have to make sure that you have target frameworks set with the multiple frameworks that you want. Then that actually will work. Otherwise, things don't work as expected. Okay, so it would be nice if there was ways to check for that before you actually run, but doing that as an analyzer, I don't know if you could actually go look at the project itself and see what your target frameworks are. That might be a really tall lift, or a big lift to do that. So in any event, got these to run. Is there a difference? And there is. If I come down here, you will see that, and this is also interesting, you'll see that, whoops, let's go back here. GUID token on the .NET Framework. There is a slight difference, 4% better difference using token. And it also takes up a little bit less memory, which is good. Switching to core, both of them suddenly get faster. Not by much, but, and again, we're talking nanoseconds here, but it is faster. It's measurably faster just switching to core. I thought that was cool. Now, if I do it with a non-generic type, it becomes much faster because I don't have to do as much heavy lifting to generate the name. But then you'll even see less noise, and you'll see that this is really a difference here. But we're also talking, we're still talking nanoseconds. Again, I want to emphasize that in both cases, running these tests using core would just be faster. Okay, and I think this is indicative of the fact that if you're going to be developing in .NET Core these days, or I'm sorry, developing in .NET, you should really be developing against .NET Core. Really, you should be developing against .NET Standard and running your code in .NET Core if you can. This is why in .NET Core 3 you're running out these desktop packs that don't make WinForms and WPF apps cross-platform, but it does allow those applications to target .NET Core. And why is this a good thing? Because it's a simply faster overall runtime. I think it's clear to me that this is not an official position from Microsoft or anything like that. To me, if I read writing on the wall, the .NET framework is, calling it dead is probably negative, but it feels like it's being sunsetted. It feels like it's it is what it is, but if we can give you the ability to target a better, faster runtime, like with .NET Core using these desktop packs, then to me, why would you use the .NET framework? You get all the benefits of .NET Core with deployments, much easier deployments if you're targeting .NET Core as well. So I don't know. I'm starting to see that trying to target the .NET frameworks is kind of a lost cause these days, in my opinion. So in any event, the other thing is somebody may say, well, that's a really, really small number, nanoseconds. We're not talking something that's huge that the user is going to see. And you're right. I do believe that what you really want to do is profiling. You want to look at where your hotspots are and nail those first and get rid of them. Okay, absolutely would agree with that. This is just in passing. When I was watching myself demoing code and doing whatever I was doing in the videos, I just caught this. This just caught my eye. And so that's why I did this. The reality is that the naming is probably not a hotspot in my code generation or mock generation. So there is a task that I have, an issue on GitHub, which is actually to do more profiling on rocks in general. And I'm glad I have the ability not to cache rock or mock generation, because if I did, that'd wipe out, it'd make profiling really, really hard. With having that in place, I'll be able to hopefully get some good numbers on where my hotspots are and being able to correct them. So again, this isn't one of them, but it is better, even though I've spent way more time just talking about this, that I'll ever gain in execution of this on all the people's computers, all 10 of them, because I don't get a lot of downloads with this library. But I wish people did. There's actually, let's see if I can find this. This is over on my other monitor. I'll pull it over here in a second. Benchmark mocknet. So some guy, let's see if I can pull this tab over here so you can see it. There we go. So some guy wrote this benchmark mocknet, which is a way to test mocking frameworks. And so I threw my rocks out there. And what's interesting is if you look at all the test results, rocks is consistently the fastest compared to all the other, mock and then substitute. You can just see the numbers here. You can see the URL up there. This actually surprised me when I heard about this, that this guy put this together, and I asked, could I submit a pull request and add rocks to it? I thought mine would be at the bottom of all these tests. It may be the middle, but definitely not the fastest. Stubs are just hand-coded, and that doesn't surprise me that those are the fastest. And with respect to all the mocking frameworks, rocks is. That really, really surprised me. Because I'm doing code generation with the compiler API, and how that just feels like that should be a little bit slower. Though I don't think any of these tests are actually testing the generation of the mock itself. I think they're just looking at how you use the mock. So that would actually be an interesting test if it actually said, it creates an iThinking object to test using the given framework. So it's still not that bad. So the point is that Rocks is actually not a bad framework. This actually gave me a little bit more confidence of, hey, it seems to actually test fairly well. Okay, so in any event, I'm going to keep this in. I'm eventually going to commit this. And when I say by commit, if I look at the code here, it's already, if I go back to Rocks, this one should be using a metadata token, and it is. Okay. Just kind of curious, if I do GUID.new GUID in the current project, yep, it's completely gone. Okay, cool. Another one I found is this generic arguments, because I figured the rest of this method, that's where most of the performance hit is coming from. And so what is that doing? I started looking at this and I started going, well, you know, I'm always calling gets constraints. Maybe I shouldn't do that. That was something I caught later. I'm using lists. Maybe I shouldn't do that. Maybe I can use arrays of a specified length. I also was passing over a specific argument. If I go back and look here in GitHub, this is in type extensions. And so you see generic arguments result. That was just a read-only class that was returning multiple arguments. C#7 no longer restricts you in that way. You can use tuples. So I decided to just pass over a tuple. That also seemed to have an effect on memory. Slight, but a little bit better. So the point is I looked at this and said, well, is there any way I could clean this up and make it a little faster? So I started playing with that. And if I come back over here to Rock's Sketchpad, long story short, because if I look at my time, I'm probably already at 21 minutes. So that's all right. But as you can see here, I had the old way. This is just the way it currently works. Didn't change anything there. And then I'll come back to this one in a second. The new way was this idea of, well, here are all the generic arguments. I'm only going to be creating as many generic arguments as there are here. So I might as well just make a string array of just that length. The number of constraints I can also know. I don't know where they are, but specifically, but I do know that if that generic parameter attributes value, oh, that's a bug. I shouldn't have done that. It should actually be not equal to 0. Yeah. No, that was wrong. It didn't matter though, because in my example here, I had 4 generic arguments. I had 2 that were constrained, so I just got lucky with my tests. If it would have been 1, 3, or whatever, that I would have been in trouble. So, but the point is, I could look at this and say, no, I don't. I only have these many constrained generic types, generic values. Okay. And then I can set them in the array. I can actually put them in the constraints only if I know that that one is actually a constrained generic parameter. Okay. And then I generate these, otherwise I return this. And I thought, this has got to be faster. This just has to be. Okay. This is why I like benchmark.net, because this was just another example of, as a developer, you cannot trust yourself. I can't trust myself. My intuition here was this would be faster. Even though I knew that the number of generic arguments that you get in a type is usually pretty small. Constraints even less so. In the large, most of the code I've seen that's generic really is, you don't have a lot of generic parameters. You don't have a lot of constraints. And I believe, if I remember right, that list is actually, it basically wraps an array. And I think its capacity is 16 to start. I could be wrong on that. But maybe that's just a little bit enough overhead. And it's kind of tuned right for what I need, because it creates an array that I can just use and not have to resize it or anything like that. Maybe if I made a type here that was really, really big with a bunch of generic values, I might see something. But the point is that this really didn't show any difference. And the more I think about it, probably makes sense, because I wouldn't, see a difference even with a list or an array. The one thing I thought of though is with the check here is to just throw in this check here to say, if you actually have constraints on it, then actually go through and generate the constraints. Otherwise, there's no reason to do so. Okay, so that's the one change I made. And if I go back and down here and show you those results, it gets pretty interesting. As you can see here, in both cases, at least with this run, that the old way with the check for the constraints on a generic argument or generic parameter is slightly faster than the other ones. Okay, both in the CLR and in .NET Core. Not much, but slightly faster. Okay, so with that said, what I'm going to do is now come back to my type extensions here, and in this code actually pull this and put that into the real code. Okay, and that should be like that. All right. So now this namespaces. Oh, namespaces is actually passed in here. I couldn't do it in my test, but there. Okay. So if I run this, this should actually not have broken any tests. Okay. Come on, go chug, chug, chug. There you go. And we'll see did it pass all the tests. One thing I've also noticed when I'm running, what broke? I broke something. What did I break? Method may only be called on a type, which type is generic parameter is true. Well, that was actually unexpected. Let's see if I actually, if I comment that out, and I comment that out. Now let's see what happens here. Again, just proving why unit tests are so invaluable. You know, that doing just, what was that, 3 lines of code that I changed it. I didn't expect anything to break. Broke stuff. Something that I did not expect at all. Okay, so even this, what was just going to be a tiny little improvement, doing that actually broke stuff. So let's put that back in here. Let's change this and run them again. And let's see if I actually get, should repeat, and it should repeat with the same thing. I was about to say too that with async tests, for some reason I've noticed constantly that the synchronous one of them in there is always taking 3 seconds, even though nothing in the test, if you actually look at it, gives a hint as to why it should take 3 seconds. So that's something I'm going to try to figure out on my own. But that feels weird. Why would that, take 3 seconds? It shouldn't. But you can see we're getting method may only be, it's the same thing. Is generic is true. Is generic is true. So the generic parameter is true. So if I do type extensions, if argument is generic parameter, and whoops, let's run them now. See, this is what happens. I try to finish on time, and look what happens. I'm already at what, 29. I'm almost at my 30-minute mark. So let's see if this helped. But even if it does help, what I want to do is run my tests. And this I'm doing totally wrong because I'm going to be running performance tests, benchmark tests, while I'm recording, and so it's like doing everything wrong. So that fixes it, which is good. But if I come back here to my generic arguments tests, I have to do this to be correct, to do it, to say what I wanted to say before. And then if I come to the program here, we want generic argument tests. So let's run that. Now, this is going to take a little bit of time for it to run. Okay, so I might pause the video at this moment and not bore you with the results so you can see what the end is. So I think I'm going to do that. I'm just going to pause it and then we'll come back. All right, I am back. It is done. So I'm just going to copy these out. Come on, go down. Copy. That would have sucked if I actually didn't use the right keystroke there. Do that. And as you can see, even with that other check, the numbers got a little higher. I think it's because, again, I'm recording right now. But overall, doing it with the check is still the right thing to do. And as a tester running, I thought about it. I'm like, that actually makes sense, because if you look at this, I go to type extensions here, all this is a bool, if it's a generic parameter or not. I think those tests where they're failing is that they're actually not, they're closed, they're not open. Whereas my tests are open, those tests are closed. So I think in those cases, you wouldn't actually be able to call this on that. So that's why, which makes sense, but it's just a Boolean, so it really shouldn't have affected performance at all. And as you can see here, it doesn't. That's still the best way to do it. So with all that said, I'm going to go back here. My tests all pass. Let me just one more time, because I'm paranoid. Just run my tests one more time and see what happens. Yes, to see the asynchronous one here, it took 3. This still takes a second. Why? That's just bizarre. I definitely want to look into that later. But they all pass, so this is all good. So I'm going to be a bad boy and say lots of little changes for performance and testing. And that should be it. Now, of course, even though with editing, this shows 35. So I'm going to probably cut out 2 or 3 minutes or whatever that. So I'm actually good on time. So I'm going to stop here. I'm going to do one more video, which actually should probably be really, really short. So that will make up for all the other ones I've done too long. Do one more video where I'm basically going to take editor config generator and make it into a .NET Core global tool. So that's what I'm going to do in my next video. And then after that, we're going to start working on those 2 projects. So I'm going to stop here. Thanks for watching. Leave any comments or questions below. See you in the next episode.